Okay guys, this is your second set of video notes. It's on graphing. It says and microscopes, but it's actually just on graphing. We're just going to spend a week focusing on our graphing skills. It will help us in science and in math. So let's get started. Okay, so this is objective 7. I can identify the parts of a graph. When we are talking about constructing a graph or making a graph, it's really important that you have all of the different parts to the graph. So we're just going to go through these really quickly. So number 1, you need to have a title on your graph. Okay, if there's no title on your graph, then people who are looking at your graph and trying to interpret it have no idea what it is that you're talking about or what your graph is about. So the title tells you what your graph is about. So this one is shows the value of Sarah's car, and this graph over here shows favorite chocolate ice cream or favorite ice cream. Oh, different types of chocolate. Favorite types of chocolate ice cream. Okay? The second thing that you need to do is label your x-axis. Your x-axis is this horizontal part right here. Okay? Every time when we are talking about what is the independent and dependent variable, we'll get to that. Well, actually, you guys had it last week with scientific method. Remember, the independent variable is the thing that you control. So whatever you're controlling goes down here at the bottom. It is the independent variable. Okay, the y-axis is this vertical side. This is the y-axis, and that is where your dependent variable goes. Remember, your dependent variable is the one that you measure, the one that changes because of whatever you did to the independent variable. So your y-axis is whatever you are measuring. Okay, and then for your x and y-axis scales. Okay, these numbers over here, 5, 10, 15, 20,000, and then 0, 1, 2, 3, 4, 5, 6, that is part of your scale. When you are doing a scale, you can't change the value between. See, these are going up by 5,000. It went from 0 to 5,000. You add 5,000 more, then you get 10,000. You add 5,000 more, you get 15,000. You are not just graphing whatever numbers are on your paper. You have to go by even intervals, and you can see that these numbers are at each of these dark lines. There's the same amount of lines in between them, okay, and the amount between them is the same. 0 to 5,000, 5 to 10, 10 to 15, 15 to 20. Okay, same thing over on this side. We're only going up by 1 each time. So 0 plus 1 is 1, 1 plus 1 is 2. It's going up by 1 each time, meaning that the scale is staying the same, okay? And then your y-axis, again, is whatever it is that you are changing, the thing that you're controlling. In this case, it's listing the different types of chocolate. And over here, it's listing the years. And again, the scale is the same. It is going up by 1 year each time. 2001 to 2002, 2002 to 2003. Okay, so pay attention to your scales. That's something that a lot of people mess up. And then the last thing that you need are your data points. And those are these points right here to show what happened in 2004, how much was Sarah's car worth. If we go up here to our data point, we can see that Sarah's car in 2004 was worth $17,500. And in 2007, that value had decreased to $5,890. Our data point is showing that. Okay, over here with our favorite kind of chocolate ice cream, if it's Reese's Pieces, we go up and we see that the number of people who liked Reese's Pieces ice cream was 5. This is our data point. Okay, all right, that's all the parts to a graph. Moving on. Objective 8. I can choose the appropriate graph to create based on my data. There are 3 different types of graphs that you can make. You don't just make whichever one you feel like. There's a certain reason to use certain ones. Okay? So the one we're most familiar with is a bar graph. That's the one that looks like this. Okay? There's bars going up from the graph. Okay? When we want to use a bar graph, when we are comparing 2 or more things. When you're comparing, you use a bar graph. The next one is a line graph, and that one looks like this. You guys are familiar with that as well. However, we only use a line graph to show a change over a period of time. If your independent variable, remember that goes on your x-axis down here, if it is a period of time, minutes, seconds, months, years, days, decades, if it is any period of time, you make a line graph. These two types of graphs are confused all the time, okay? This is for comparing. This is for showing how something changed over a period of time. If we go back up to our other slide, we can see that when we were talking about Sarah's car, we used a line graph because down here at our x-axis, our independent variable is year. See, it says year right there because year is a period of time. It shows how the value of her car changed over a period of time. That's when we use a line graph. And the last thing that we need to know is when to use a circle graph or a pie chart, and that is used to show parts of a whole. So anytime you have 100% of something or 100 people, okay, let's say 50% of students love science and the other 50% love language arts because nobody likes math. Ha ha ha, don't tell Miss Meyer. Okay, moving on. So anyway, circle graphs, pie charts, we use that to show parts of a whole. All right. Bar graphs, again, they compare two or more things. Here is a bar graph just to give you an example. Circle graphs, parts of a whole. Remember, all parts have to add up to 100%. If we took all these percentages over here, they would add up to 100%. Same thing over here. Okay? They have to add up to 100. And line graphs, again, showing a period of time. Remember I told you that your independent variable, your x-axis, which is this horizontal axis, has to be a period of time in order for you to make a line graph, because this is months, that is showing a period of time. Okay? This gets confusing when you have more than one set of data that goes on the same graph. For example, on this graph, we have two companies, and we're showing their profit in millions of dollars over a period of time, over a period of years. Okay, so first of all, we know it's a line graph because our x-axis is a period of time. Okay, so if we're looking at the profit that our companies made, we can see that Company A obviously was making a lot more profit than Company B to begin with. But in 2004-2005, both companies made the exact same amount of profit. So both companies are going to share that point. It's the same exact location. You don't put it a little above or a little below or next to. It goes, and there's only one point on this graph that is for 2004-2005 and equals $4 million. Okay? It doesn't go above or below. That would mean that a company made a little more or a little less than the other company. And it doesn't go to the left or right because that would indicate that it either belongs to 2003 or to 2005 over here. Okay, and that's not true. Because they both made the exact same amount of profit in 2004-2005, they have to share the same location. Okay, so both lines go to that dot. It doesn't matter if it's red or blue on top. It just matters that they both go there. Okay? We will talk about that more in class when we practice with graph construction. Objective 9. I can describe what is happening based on the shapes of the graphs. These are distance time graphs, and we are going to get into more with these as we get into our physics unit and our forces in motion unit. We are going to be actually doing some labs with distance and time to see how the distance changes over a period of time. But you can tell just by the shape of the graph what's happening. Okay, so if we look at this, this is distance and this is the amount of time. So as time is increasing, our distance stays exactly the same. Because our distance isn't changing at all, it's not going up, it's not going down, it tells us that whatever this object is not moving. Time's increasing, distance is staying exactly the same, the object is not moving. So that's your first graph. Your next graph. This one shows that as time is increasing, distance is also increasing. Because it's a nice, straight, steady line, that tells us that this object is moving at a steady, constant speed, okay? Because the graph is a straight line, it's saying that the same distance is being moved in the same period of time every single time, okay? Because it's a straight line. So it's showing the object is moving and at a constant, which is down here. I wrote over it, sorry. It's moving at a constant speed, okay? So if you have a straight line like this one, meaning your time is increasing and so is your distance, that means it's moving at a constant speed. Next one. Just like the graph right before it, this one is moving at a constant speed too, but the distance is going down. So that means it's coming back to something. Your distance is decreasing. So as time is increasing, that's an eraser, I need a marker. As time is increasing, your distance is decreasing. But because it's a straight line, it's decreasing at a constant speed. Okay? This next graph, because this one is not a straight line, it's showing us that our speed has changed. So we start going out a constant speed and then our line gets steeper, our slope gets steeper, which tells us right here where the curve of the graph is acceleration, meaning it went faster at right here at this point in time because we didn't have such a steep line, our slope was pretty low, and then all of a sudden our slope got very steep, meaning that this is showing acceleration. So if you have a curve in the graph like that, that means acceleration, and it can also go this way, meaning that it's slowing down. Okay? Sometimes graphs tell stories, okay? So if we look at the shape of this graph, we can tell that at the beginning, this object was increasing its distance, and the line is pretty steep, meaning it was going pretty fast. Then when it got to this point in time, it stopped moving, okay? It's because it's a flat line. So our distance stayed the same for this amount of time, and then whatever our object was started coming back, and it's not as steep as the beginning line, so that indicates that it came back at a slower velocity, okay? And you can read that over here if you didn't get what I just said. All right, last is called a graphing story, okay? We can draw a graph to represent what a different story is telling us. So let's start. We're going to make a graph. First, Johnny's mother brought him to school, so she's bringing him to school. And then she came back home. She came all the way back home. They started at home, they went to school, and they came back home. Then it says she stayed home for 3 hours. Remember, if your time is increasing but your distance is not, that means that your line stays the same. Let me change my color so you guys can see. Okay, so Johnny's mom went to school, and then she came back home, and she stayed home for 3 hours. So this means that she was home and she didn't move. She stayed home for 3 hours, meaning she didn't leave home or go anywhere else because she stayed in one spot. Her distance did not increase. Okay? Then she went to the store for 2 hours, which was on her way to Johnny's school. So she's going to the store, but we're not going to go up as high as the school because it's on her way to school. So we can't go all the way up there because this distance right here represents school. Okay, so it's not as far of a distance. So she stayed at the store for 2 hours, so we're going to draw a flat line, meaning she stayed in the same location for 2 hours. After she was done shopping, she continued to Johnny's school. So we're going to go up to Johnny's school, and we need to be, again, at the same height that we started with for school at the beginning. And then she went back home for the rest of the day. So there, we're going back home, and then she stays there for the rest of the day. Okay? I'm going to go through that one more time just to make sure that you understand what I just did. So let me erase this, and we'll go through it just one more time. Here's my graph. And I'll change my color. Okay, so Johnny's mom brought him to school. She came back home. She stayed there for 3 hours. She went to the store, which is on her way to Johnny's school. She stayed there for 2 hours, then went to pick up Johnny from school, came back home, and stayed there for the rest of the day. That is the shape of the graph that matches this story. Okay? That is all I have for you this week. Please, if you have any questions, bring them to class so that I can answer them in class for you, or see me before homeroom or at the beginning of class during our bell ringer time. All right, guys, see you in class.